So hello everybody and welcome to the Institute of Refrigeration's World Refrigeration Day celebration. We're just allowing everybody to drop into the meeting room as they join us today, this afternoon. My name is Miriam Rodway. I'm the Chief Exec of the IOR and I'm going to be talking us through the program as we go through everything today. We've got quite a lot going on. We've got lots of people who are involved closely in working with the Institute on careers events. We've also got a lot of students, young people and award winners who are going to share their experience and hopefully give you some inspiration to help doing some more work to promote refrigeration careers. And anybody who's interested in joining the industry who might be part of the call as well, hopefully you'll get some good ideas there. So really, I think that we've got everybody in at the moment that we needed. So again, thank you very much for joining. And I'm going to hand straight over to our president, Mike Creamer, who's going to give you a welcome.
Good afternoon and welcome everyone. Thank you very much for sparing the time to join us today for our Cool Careers event, which I hope you'll find informative and enjoyable. Well, as your president, I would normally deliver an address at our annual dinner to an audience of several hundred, all dressed in DJs and evening gowns, but I'm sure you'll understand why that's not possible on this occasion, so maybe next year. So I'm instead speaking to you from my hotel bedroom in Manchester, where I'm working on the huge water chillers with Mark Forsyth, who'll be speaking world skills later. I'm really excited about today's events, given their special importance to our industry. So moving on to our program, if we may, in the next slide, you'll see that we have a lot of interesting and relevant topics for you. These focusing on recruitment of the next generation of engineers and promoting careers within schools. Then we'll have 3 research students from UK universities, each delivering a 3-minute thesis on their research, one of whom will be voted the winner of the Ted Perry Award. So I'm looking forward to that. They'll be followed by 3 trainees and apprentices telling us why they decided on our industry for the future, for their future. We'll also have an overview of world skills, showcasing our UK engineering. And we also have 2 other awards today, these being the Award for Lifetime Achievement by a Service Engineer and the Ted Perry Student Research Prize. So moving on, what are cool careers? Well, the Institute clearly recognises the fact that we have critically important need for more skilled men and women in our industry sector. I've personally been very aware of this situation for the last 30 years, and that's why I've dedicated so much of my time and effort toward the training and certification of competent engineers. But the need is now greater than ever before. Young people about to leave school have many career choices available to them, and if we do not make them aware of the excellent career opportunities that we can offer and the variety that our air conditioning, refrigeration and heat pump sector has, we will lose them to other industries, perhaps indefinitely. Hence the tremendous efforts being made by the STEM programme, STEM standing for Science, Technology, Engineering and Maths, all of which are essential underpinning components to our technical sector. We'll be learning more about this very important activity from Jacinta Caden today, a STEM ambassador and a member of the IOR Education Committee. Moving on to the next slide, Women in Engineering today. We had the Women in Engineering Day yesterday, with this theme being engineering heroes. In my long career, I've had the opportunity of working with many women engineers in electronic engineering, quality control and building services. Given the industry shortage of engineers across the wide range of essential skills and job roles, it's obvious that more women in our industry can help us to solve our skills shortage dilemma. I'd like to see more women involved in design, project management, product development and manufacturing. I've seen women manufacturing critical electronic components and diligently brazing heat exchanger coils, so they can pretty much do anything. I also remember well that it was diligent women constructing our very complex Spitfire aircraft wings. And it was Katherine Johnson, a NASA mathematician, whose calculations of orbital mechanics were critical to the success of the early US space flights. And Dorothy Vaughan was the supervisor of West Area Computers, NACA, in 1949, which then became NASA. So just think how much women might be doing for us and themselves in our vast industry. The question is, how do we find them? So let's do our best to recruit them. So moving on to the next slide, why do skills matter so much for our sector? In order to underpin our expanding industry, we must provide the essential education and training to our young engineers of the future, enabling them to carve out interesting, exciting and rewarding careers in air conditioning and refrigeration, whilst doing their best to protect our planet's environmental future. And we need as many of you young engineers as we can get if we are to deliver efficient cooling and refrigeration to the world. Humankind is highly reliant on cooling and refrigeration. So given we cannot do without it, let's make sure that all our systems are as technically advanced and as efficient as possible by developing highly skilled air conditioning and refrigeration engineers. It's estimated there are over 5 billion air conditioning and heat pump systems and 15 million people working in our industry across the world. Then add to that the colossal number of installed refrigeration systems. Accordingly, our industry requires well-trained, skilled and certified engineers, and we need thousands of you, both men and women. This is why technical training reinforced by practical skills is so important to our future. So some of you may ask, what are the career opportunities within our AC/HP industry? Well, the job opportunities include design engineer, service engineer, field technician, R&D engineer, commissioning engineer, controls engineer, BMS engineer, software engineer, applications engineer, and sales engineer, and even more. So note the emphasis on engineer, and this is why we need engineering training so much. You may also eventually become a supervisor, managing director, or a director of your own company, and perhaps start your own business in air conditioning and refrigeration, employing other people. So next slide for our IOR top priorities. From the start of my 2-year tenure, I've had a very clear institute objective in mind, and I'm delighted to tell you that out of 8 possible objectives, the IOR members voted on 4 top priorities, all of which closely align with mine. You can see the top priorities listed here. Note that the great emphasis on education and training, the key that unlocks the door to great and exciting careers in our industry. Moving on to slide 8, what are our members doing to address this? Here you can see what we're doing to meet those priorities, where we have several working groups working on apprenticeships, design engineers and operative training. We have networks for STEM ambassadors, young engineers and young members, employers offering work experience and the Engineering Council. There are education guidance notes on working in schools, CPD, skills roadmaps and apprenticeships. And there's PR and publicity covering articles, news, profiles of students, competition winners, and the importance of training and our beyond refrigeration work. Moving on to our next slide. Here you see some of the activities being undertaken by Institute members. Naturally, one must also build up experience in order to become fully capable and competent, especially given the wide array of engineering skills that one requires in air conditioning, refrigeration, and now heat pump technology. I've been a member of the Institute since 1984, and in those 37 years, this wonderful institute has been a great asset to my career, with me accumulating most of the Institute's technical papers and data, many of which have proven so useful to me. It's my hope that you will also use the Institute to help you as you pass through your air conditioning and refrigeration career. And whilst I've added many strings to my bow of activities, I'm still wholly dedicated to passing on the essential technical knowledge and practical skills to both experienced and new engineers entering our profession. 31 years on, and we are still busy training and certifying engineers in all of these essential disciplines. And there's so much to enjoy and learn within this wonderful industry, including mechanics, thermodynamics, electrical engineering, psychometrics, fluid flow, refrigerants, compressors, heat exchangers, control devices, electronics, software engineering, air movement, air handling, ducting, pipework, pumps, and much more. Indeed, as it's frankly impossible to learn it all and to know everything, you certainly won't be bored. And there are so many applications our industry has to serve, including food production and preservation, pharmaceuticals, warships, hotels, office buildings, cinemas, hospitals, laboratories, and even nuclear power stations. So you'll find yourself involved with so much variety, your career will always be interesting and enjoyable. If you like calculations, there's more than enough to learn. If you enjoy using your hands, there are many practical skills to choose from. Or like me, you may want to aim yourself at the critically important reduction of our energy consumption as we work towards the goal of net zero CO2 emissions for the well-being of our planet Earth. You may already know that more than 17% of global energy is consumed by cooling and refrigeration, We're also heading for a substantial increase in heat pump installations at the domestic level. Fortunately, heat pumps are 3 to 4 times more efficient than gas and oil-fired boilers, and so we should see some substantial reduction in CO2 emissions and global warming. But this gives you some idea of the sheer size of our industry across the world. This is why one of the Institute's working groups, headed by Professor Graham Moment, has worked so hard to set out every possible means of reducing energy consumption and the global warming impact of our RECHP systems, which is one of our 4 top priorities. Consequently, we're going to need a massive increase in the number of capable engineers to install, service and maintain our ever-increasing base of installed equipment and systems. And we need more design engineers to develop products and to design energy-efficient installations. Indeed, this is why another Institute working group is developing an employer specification setting out the essential skills and requirements for design engineers. And I take this opportunity to give thanks for all the hard work and the input from all the members who've contributed so much to our working groups. Moving on to World Refrigeration Day, I'm sure that most of you are fully aware of the great thing and great work inaugurated by our past president, Steve Gill. This theme is cooling. This year's theme is Cooling Champions, Cool Careers for a Better World, and the IOR has been fully supportive of this great initiative and will continue to support it into the future, especially given the worldwide awareness that WRD is creating for our vital industry. Well, that's it from me for the time being, and I'd now like to hand you back to our excellent CEO, Miriam Bilbay. Thank you.
Thank you, Mike, and thank you for joining us from site. I mean, that is the exciting world of refrigeration, where we never know where we're going to be from one moment to the next. So it's great that you're able to take the time just to run through that. And sorry we couldn't invite you to speak at the annual dinner this year. So coming back to our program, we have an awful lot of different activities planned today, talking, say, to students, prize winners, and technicians. Our first presentation is a recording. We've had a little bit of technical difficulty, so hopefully this will go okay. I'll ask Lisa to start this off with John Skelton, the chairman of our education committee, and a personal journey through skills promotion.
Good afternoon. My name is John Skelton and I'm chair of the Education and Training Committee. Unfortunately, I'm unable to join you in person this afternoon, but I'd like to thank the Institute for allowing me to record this short video. World Refrigeration Day has given us all a great platform to talk about our industry, and it's given a wider audience an insight into the importance of the amazing things we do and a glimpse of the exciting and diverse careers available across our sector. I was keen to be involved today as I feel it's important that we all face into a challenge that will potentially affect our whole industry and could limit us from fulfilling our full potential. Anyone who has attended the Institute dinner over the last 10 years might be able to hazard a guess to what I'm referring to. It has to do with seeing the same group of predominantly white males every year in their best bib and tuckers. We have an ageing demographic, and yes, it's not lost on me that I'm one of those ageing white middle-aged men. Many of the faces we all know will be retiring in the coming years, and this is something that is being played out in businesses across our industry. None of us are getting any younger, and the average age of our industry is certainly getting older. We have some amazing opportunities heading our way, but we need skilled individuals to grab those opportunities and run with them. We have an ageing demographic and insufficient qualified individuals to take their places. Technology is changing at pace, the pressures on our businesses are immense, but it feels like training is no longer part of our DNA. However, training is more important now than it's ever been. So it's time we started dedicating the time and money to rebalance things if we want to stay ahead of the game. I, like many, sort of fell into the industry through a family friend, but I was lucky enough to serve a fantastic apprenticeship with Sainsbury's. At the time, apprenticeships were more commonplace, but for lots of reasons that isn't the case today. I hadn't considered a career in engineering before that opportunity surfaced, and it certainly wasn't a career discussed at school. It won't surprise many of you that I wasn't the brightest individual at school, and I frequently got in trouble. The reason I mention this is because I vividly remember my head of year telling me that if I didn't back up my ideas, I'd end up getting expelled and working as an engineer with oily hands. He made a real point about the oily hands. He actually said mechanic rather than engineer, but there is still a stigma around engineering in some circles and a misunderstanding about the amazing roles that are open to individuals, specifically for us in our industry. I must admit, I thought things had changed for the better, but a friend of mine in the industry told me a story relatively recently about a tour he'd organised for a local school to his manufacturing facility. He actually overheard one of the teachers tell a misbehaving student that if he didn't behave, he would end up working in a place like that. Now that's just downright rude, but it does emphasise the battle we're up against. It's tough to attract the right individuals at any age, so we need to be considering how we engage with school children, college students, graduates and our local communities as the competition from other sectors is fierce. Attracting the right individuals is also about understanding their needs and aspirations. Maybe the way we've done things in the past is no longer good enough, and we need to consider some new approaches to recruitment, training and retaining good people. If we really want to capitalise on the opportunities that will come with the move to carbon net zero, F-gas and other changes in legislation, we need a workforce that's fit for purpose, and to do that we need to change the perception of our industry. We also need to consider how we can be more inclusive. If we're not, we won't be harnessing the best talent out there, and we won't have a workforce that reflects the diverse communities we serve. How can we cater for and deliver an inclusive strategy unless we're engaged with our communities and understand their needs, and how better to do that than by ensuring we have a diverse workforce? Our businesses will be far more productive and profitable with well-trained and focused individuals, so we need to ensure training, education and personal development is part of our day-to-day business. The challenge ahead really does need a step change in attitudes. Do we need to take a leaf out of the British motor car industry? They look at training and education as their collective responsibility to ensure they have a world-beating industry. Also, it's not just about engineers. It's also about attracting the right individuals to want to become involved in the support functions that help our industry function smoothly and operate efficiently. So how do you get involved? Firstly, this shouldn't be seen as a chore. It's a great way of giving something back and feeling good about yourself. You can work individually or with your business to engage local schools, colleges, universities and communities to explain what a career in the RACHP industry can look like. There's a host of tools on the IOR website to make any engagement a success. You could also consider signing up as a STEM ambassador and join the great work that Jacinta and others are doing. Again, there's some great advice on that IOR website. I have to admit I haven't hosted a STEM activity yet, and I'm dreading getting mauled by some primary school student, but my colleagues that have done one have all said that it's a liberating and rewarding thing to do. These things are daunting to do, but also rewarding. They are also great things to do for your own personal development. They can help develop confidence, presentation skills, and give you a real sense of achievement and reward. Or how about enrolling some apprentices onto the RACHP Trailblazer scheme? It's an employer-led scheme that will give any successful apprentice an ideal platform for becoming a rounded engineer and to develop their career going forward. Or you could continue to support World Refrigeration Day, which has done an incredible job of promoting our industry in a positive light across the globe. I'm really optimistic about what tomorrow will bring, but we need to take responsibility for ensuring that our industry and our people are best placed to rise to the challenges ahead so we can grab the opportunities and fulfil our potential. We can all make a difference, but just imagine what we could do if we work together. Thank you.
So thank you to John for putting that message together. Obviously, a very heartfelt message from him based on his experience. And I hope that is one of the things that will help to inspire you as you think about what you might be able to do. Actually, before I hand over to Jacinta, I just wanted to say that we had some great news yesterday that Linda McVitie, one of the Institute Fellows and really active in our IOR Scotland group, had been nominated as one of the top 50 women in engineering. So that was a really great achievement on behalf of Linda, and we very much congratulate her. And I think we can add her to Mike's presentation in future in terms of inspiring women who are actively involved, not only in promoting science careers, but also promoting the refrigeration industry. So just a little extra information hot off the press for you. I'll hand straight over to Jacinta. She's been doing a lot of work on STEM, both in terms of volunteering herself, but also encouraging more people to get involved. So handing over straight to you, Jacinta.
Good afternoon, everyone. Thank you, Miriam. So if you can move on to one of my slides, that would be great.
There you go, Jacinta, is it up for you? Can you see it?
No, it just disappeared.
We actually got it on the screen here, so I'm not quite sure what's happening with you.
Okay, well, anyway, no, I've got a paper copy. It does. I hopefully people get the message anyway. So thank you. I'm probably going to repeat a little bit about what both John and Mike have said, but again, it's just shows how important the message that we have got to say really is. So people might be asking, like, why, should we promote careers in refrigeration, air conditioning, and heat pumps? And it's been highlighted that we've got a shortage of various skills within the industry, and not just engineering, particularly engineering, because it gives you the greatest background and foundation into all the other areas that the sector has to offer, such as marketing, admin, any other skill that the sector needs. So it's really about promoting everything, not just necessarily engineering, but today we're going to focus on that. So we need to, it's a continuous journey that we go on to try and encourage and inspire the next generation. So that's one of the reasons that we need to kind of get on board, I guess. Refrigeration, air conditioning, heat pumps is a sector that's, I find, hidden and overlooked a lot because it's not something you see or take much notice of. The general public don't tend to do that. So we kind of have to make the industry a little bit more attractive, try and find a way to make it a bit more attractive when you're comparing. For example, I always use the comparison of aviation. You go to any careers fairs or anything, any big skills competitions, they've got great big aircrafts there to automatically grab your attention. So we're in competition with other sectors, and I think it's important that we try and get on board and support where we can. I mean, employers and colleges already do strive to deliver excellence in the sector, and there's constant improvements and schemes and apprenticeships that people try and get behind. So results show that 73% of 11 to 14-year-olds don't know what engineers do. 69% of parents are unaware of what engineers do, and 42% of teachers are not confident enough in giving advice on engineering. Now, those figures came from a UK report, an Engineering UK report, State of Engineering 2018, and I myself am on a course at the moment with STEMazing, and that's how I came to know those figures, and it kind of staggered me really, like that the younger, more impressionable ages are losing out on what actually could turn out to be a great career for them. And as John Skelton said, most of us fell into the industry, and that's not what we really can rely on. We need to kind of push towards more strategic approach on how we get more diverse people into the industry. So another reason why, obviously, RACHP is present in every sector in some form or other. And I think that was really highlighted the last year, particularly, how critical our sector is, producing critical services to the food supply chain, pharmaceutical industry, data centers. Without data center, we wouldn't be able to have this function today of a video conference or webinar, and hospitals and so on. So it's there, as I say, it's just overlooked, and I think that's one of the reasons why we kind of really need to push the profile so much of the sector, because it is a great sector to work in. So you're probably going to ask now in your head, why or how do we do this? So it's been mentioned recently, the last couple of speakers, STEM. So STEM is obviously science, technology, engineering, maths. So STEM learning are a group or company that share similar objectives to the IOR when it comes to raising the profile of those subjects. The wonderful thing about RACHP is that every subject of STEM is in the one subject, which is RACHP. So whether you're interested in science, technology, engineering, and maths, refrigeration, you will find something in refrigeration that would suit you. So, and more. So I think STEM learning rather also have the facility to become a STEM ambassador. And that means that, people like me, other people on this panel today are STEM ambassadors who volunteer our time. Our companies allow us time to go and engage with schools, children of younger ages, 5 or 6, right up to colleges, on how great the industry is. And I suppose it gives us a platform, because they already have the platform. It's a national a nationwide, should I say, a platform that they've got, and it's something that we can bolt onto the back of and engage with it more on a local level. So wherever you live in the country, you will have a local hub, a STEM ambassador hub that can engage you with your local schools, your local colleges, your local activities that are going on. So it's really activities such as workshops, speed networking events, career fairs, virtual sessions, face-to-face. I've got something coming up not in a few weeks' time where I'm getting to go back into a school. I haven't done that in quite a while. So I've delivered sessions over the internet like this, and it's great, but it's just not the same. You don't get that feedback. Sometimes the class is on mute or something, and you can see them doing and listening, but you just don't get that immediate energy and feedback. So I think that's how I see us as an industry. It's not the only way, but it's an existing platform that is working, and something that so many of us have already got a great reward from getting involved. So that it would be the how. As a result of doing all this, as I said, it raised the profile of the industry among those who can influence the future generations, such as teachers, parents, mentors, organizations, all of the adult, I would say, world can, we can influence, we can take it as a responsibility to give back, as John said, and to feel great reward for encouraging and inspiring others, especially particularly when they're at an impressionable age. By doing this, we also get to support local community, industry, and economy. So, for example, if you're working for a company at the moment and you're interested in getting involved, there is great opportunity for you to engage with your local STEM hub, local schools. And one of the big bonuses, I guess, about being a STEM ambassador is that it's recognized. Schools automatically recognize STEM and STEM learning and STEM ambassadors, and particularly because as you go through the process of becoming a STEM ambassador, you go through a background check. So you automatically are endorsed to work with children. And once you get through that process, you might see my badge, but you get a little badge to say that you're a STEM ambassador. So it's just, again, it's something else that makes you feel like you've achieved something. 92% of STEM ambassadors say that their sense of achievement or reward is increased. And like John said, your confidence, your presentation skills, your personal development is, as well as raising the profile of the industry, is I wouldn't not do it. I wish I could do more. It is a full-time job in itself, I guess, depends on how much you sign up to different activities from their website. And I found teachers in general are just so grateful for, you turning up. First off, they're delighted that you turn up. They're delighted that they've got something else to talk about, an industry that they've not heard of. And in particular, there's one particular school I did a session with, and local to them was a really large food factory. So refrigeration, air conditioning was a massive thing for that school, because many of their friends or family may already work there and not even realize what kind of equipment or what kind of services are in there, and that they might be able to get involved in, not necessarily have to do what their friends or family do, working on the production line or something like that. So it's kind of looking at your area, what's local to your area, and kind of making a strategic approach as to how you can get involved and get the best result for you as you get out what you put in, is what I would say. So then the resources, there's quite a lot on the IOR website. There's even more on the STEM Learning website. There's a link there. But if you just search for STEM Learning or STEM Ambassador, you're automatically brought to their page. There's guidance notes on the IOR website on how to engage more. I could be here for an hour myself just telling you how to do it, but the guidance notes are there to guide you. And of course, fantasticfridges.com is something that the IOR have put together and put great time and resource into. And there's so many videos, resources there that you can use to, depending on what the task or activity is, that you can borrow information from and make your sessions your own. And it's about getting into it. And the more you get into it, the more you enjoy it. And then the easier it becomes, because the first one or two times does get a little bit daunting, but at the same time, it's so worth it, I think. And for me, I don't have children myself. I don't, I just don't know how to engage with them. They're not, my friends are, it's something alien to me, I guess. And at the same time, going through this has kind of brought it to me. And I got something back from it. So I imagine if you've got children of your own, you would appreciate it even more. So I think that's it. If anybody's any questions, I'm more than happy to answer or guide or get in touch with me directly or through Miriam or whatever it is. But that's why I think, STEM learning ambassadorship is the way forward for the industry. Not the only way, as I say, but one of them. Thank you.
Thanks, Jacinta. And sorry, you lost your slides there. I know it's hard to talk to thin air, but we could see them and it was all good. So that was fine. So you've given a really great overview of something tangible that people can do. So we always hear people talking about skill shortages. But what we're saying is there is something, it's not something for someone else to do. It's something that everyone can do. And we have a team there, Jacinta and others who can help you. And we are trying to set up some networks. So anyone interested in either going through the STEM process, or if you're already on STEM, drop us a line, and we have meetings we're going to be setting them up every 3 or 4 months so that you can share ideas and see how it goes. So thanks again, Jacinta. Pop questions in there for her if you want to into the chat box, and she can reply directly and give you some more advice. So we're moving now on to the next part of our program. So this time we're bringing in some of those young people who are inspiring or have been inspired to join our industry, and hopefully will then inspire the next set of young people. So we're doing something called a 3-minute thesis, which sounds a bit scary. What it is really is taking some top students who've been nominated for their research, their groundbreaking research, and inviting them to present to everybody today, just for 3 minutes each. So it's very, very tight time frame here, to give us a little summary of the work that they've probably been doing for about 10 years. So we are giving them a real challenge to try to make this innovation work really makes sense to people here. So we also have a number of judges joining us. We have 3 researchers from different universities in the UK, and then we have 4 judges. And I'm delighted to say that our 4 judges, you can see their pictures there, or you might be able to track them down in the Zoom pictures. And they are all past winners of the Institute's Ted Perry Award. The Ted Perry Award was set up by one of our past presidents some years ago to encourage students to consider refrigeration-related research. It's been going for quite a few years, and his family actually provides some support to provide technical material to the winner. And then we have a sponsor, Hawco, who will provide some prize funds to encourage the students to participate. So we're going to invite them each to speak for a very, very strict 3 minutes, at the end of which we will then take our judges into a separate room and they will consider what they have heard. They will also have already seen the full summary of the thesis and some citations from the student tutors, etc., the nominees, and they'll be considering who should win the prize this year. So the first year we've done this judging live, and then at the end of our meeting today, they will be bringing back the winning researcher to announce the winner and let them know that they have won and say a few words. So I think that's all the background that I need to say, and we'll come on to our first. Oh, and I also want to say, if you had any questions for our researchers, you can pop them in the chat box as well. We're going to come to our first researcher who will speak. It's Nasreen Basha. So hopefully, Nasreen, if you just want to unmute yourself and say hello, that I know you're ready to go.
Hi.
Hi,
Yeah.
hi there, thanks. So here's Nasreen's slide. She is going to talk to you for a full 3 minutes. I have a timer here and I will have to interrupt you if you overrun. So I will leave you to go forward. Nasreen is from City University of London and she's going to tell us about her work. If you'd like to start now.
Hello, everyone. What if I tell you that, you could have efficient compressors with minimal design changes? So that's where my research is. So the compressed air systems in the UK emit around 470 kilotons of CO2 annually, which is a huge problem. Therefore, in order to reduce some emissions, what we need is energy efficient compressors. So here my research, I focus on twin screw compressors, as these compressors are used in refrigeration and air conditioning systems. So nearly 83% of twin screw compressors are oil injected machines, and oil in these machines is important for cooling, sealing, and lubrication. However, if we have excess amount of oil, that can add to increased losses and therefore inefficient machine. So therefore what we need is optimal oil quantity. Though these machines have been in operation since 1950s, but there has been limited publications in the area of optimal oil injection within these machines, and as well as the distribution of oil in the compression chamber. And that's mostly limited because experimentally there is no way of getting, it's a very hard way of getting an optical access to visualize oil distribution inside the compression chamber. Therefore, in my research, I use computational fluid dynamics to understand the distribution of oil as well as temperature within the compression chamber. Here in this case, I'm showing you a test case of oil and temperature distribution for a typical industrial compressor, where one of the conventional injection is through single oil injection ports, and that's shown on the left-hand side of this slide. So when you see that the single oil injection port that's placed on the female rotor side, the red color region shows the oil distribution. So there is high amount of oil on the female rotor side and low amount of oil on the male rotor side. So this sparse distribution of oil in the bottom figure, in the temperature, you can see the red regions where there are high temperature spots. Therefore, if we pick the same amount of oil on the right-hand side of the figure and we distribute that evenly, then the oil is well distributed, and that reduces the temperature spots in the compression chamber. So the difference between the conventional and the improved design is a reduction of 35 to 40 degrees of compression chamber temperatures. And this reduces the power consumption by 2.3%. And more importantly, the specific power is reduced by 1.8%. So therefore, in a summary, this sort of a research being applied to a wide range of compressors, then we could see the improvement in compressor efficiency. And then we add up over the compression and operation cycles, then you see the savings in emissions. Therefore, this propels us towards our goal of environmentally friendly compressors, which are useful for a far greener, healthier planet, much like the divine tree in my slide. Thank you.
Thank you and well done. You are pretty much within your 3 minutes, maybe a millisecond over. So thanks for that, Nasreen. So there was a lot to take on board there. So I can ask our 4 judges if they'd like to unmute briefly. We've got time for 1 or 2 questions. If you'd like to give Nasreen the opportunity to say a few more words about anything she's suggested. If you want to unmute yourself, the judges, you're all on mute at the moment.
Hopefully I've unmuted.
Yeah. Oh, Rob, sorry, Rob, do you want to kick us off?
Yeah, you've obviously got a profile there that you've looked at and you've shown in your slide here and in the reports that you submitted. How adaptable is the work that you've done for different rotor diameters, rotor lengths? Because obviously that varies from different sizes of screw compressor.
Yeah, that's a good question. As far as we understand how the oil is being distributed, if you could have a way through computational fluid dynamics, we could understand how the oil is being distributed, then we could always improve where the location and position of oil injection port to be. It simply said, like pour your oil where your heat is, so that you see an improvement in adiabatic efficiency.
And when you looked at this work, was it for one diameter? There was one diameter mentioned within your report. Have you looked at different diameters and lengths?
Yes, yeah, we have looked at a bigger compressor as well, but the lobe combination, which is 4-5, it remains same. Also, I would like to mention somehow in the bottom of the slide, I had a reference to the paper that was published in Applied Thermal Engineering Journal, but there is a Zoom tab that it's not showing the reference, but yeah, so I can put that on chat for more information on this research.
Thank you.
So do we have any more questions from anyone else on what you've read or seen or heard today? There's a question from the audience. Have you compared the cost of manufacturing changes to the cost of energy saving?
Since this is a very minimal design change of adding another oil injection port, so we thought that the cost would not be very substantial. But obviously, this work, another of my colleagues is continuing with this work, so that would be the plan for future. Okay, brilliant. So thank you very much. I think we are about there on that one. I will reset my counter and we'll thank you very much for that summary. And then we're going to move on to our next person. And there's another question in the box, actually, Nasreen, if you want to answer it privately. Yeah, so coming now. Okay, thank you. We'll let you go. So our next person is James Bull. James, I can see you there and you are unmuted. So that's excellent. So James is from the University of Portsmouth and we'll talk about a novel compressor design, development, sizing, and optimization. So we've got your slide up and you're good to go, James. I'll start you now.
Awesome. So the air conditioning paradox is one of the most difficult challenges within air conditioning and refrigeration industries. As climate change drives the temperature of the globe higher, the energy requirements for cooling systems increase, specifically ones that are linked to external environments. So as we aren't currently able to run fully renewable power grids, more fossil fuels are being used to meet the energy demand of these air conditioning systems, which then contributes further to the temperature increase of the globe, which then links back to the paradox itself. So ensuring cooling systems work as efficiently as possible is more imperative than ever. The compressor is arguably one of the most vital parts that affects the performance of a cooling system. Well, it's the part that consumes the power. So this thesis explores the optimization process of a novel centrifugal compressor design and further investigates the methods with which are used to design centrifugal impeller blades. There are currently a variety of different design methods that exist, some based on geometry variation, others based on formula, and others based on design database. This research revolves around a design database method that uses centrifugal compressor blade design simulated using a high-performance computer and then inputted into a design database for analysis. The database contains all the geometrical parameters that make up the shape of the blade, the fluid flow parameters that would be simulated for the blade, and the simulated outputs. The The analysis of the database using an optimization program produced 2 optimal impeller blade designs that can be used in a 2-stage compression system for a required pressure ratio and cooling capacity. However, it's important to note that that was with one specific working fluid. So if you did want to change the working fluid, it doesn't necessarily mean that these 2 designs would be optimal for a different working fluid. And further analysis of the database using multivariate statistics, specifically multiple regression analysis, offers an understanding into which parameters have the greatest impact on the performance of the blade. So as you can see on the slide, there's a power regression modeling graph that shows the difference between the power prediction equation and the simulated power of the CFD simulation, which shows a reasonably good fit. For anybody that's a stats nerd, the R-squared value of that fit is 89.35%. So prediction equations like these not only highlight the key geometrical parameters that have the greatest impact on the performance of an impeller blade, but they also provide insight into how adjusting these parameters could then achieve a desired result. So this has significant relevance when considering the design method of an impeller blade for the future, because you can utilize these prediction equations to almost shape a blade into the way you want it to look so that it will achieve so for this example, a lower power required to achieve the same pressure, lower power required to achieve the same efficiency.
Thank you, James. I'm going to have to interrupt there. I'm sorry, and stop you. So hopefully you've got your main points across in your 3 minutes. And again, any more questions, you can ask him directly into our question box as we move on to our 4 panelists, our judges, to maybe tease out a little bit more information from what James has been telling us. It's all about compressors today, it seems. So Jolyon, you're unmuted. Was there something you wanted to say?
Yes, I did. Thank you for a very interesting presentation. With your database prediction tool, I'm assuming that the only way it works is by filling that database with all of the various analysis parameters. And you mentioned that you needed to potentially do that for each different type of working fluid and so forth. I was wondering if you could just comment therefore on how long it might take to optimize for a new working fluid, or how long the process would take you therefore to take your design requirements through to an optimal design.
Well, actually, part of the next stage in the research would be incorporating working fluids into the database. So then properties of a fluid could be considered an input characteristic. So you could then change the fluid, and in theory, it could then change the predicted result. However, the database would need to be scaled massively to incorporate all the different kinds of fluids and operating conditions. I would say for creating a new database for a different fluid, it would be a lot quicker than this initial database was created, because the method for populating the database was almost optimized itself when doing it the first time. So if I had to do it again, it could be a month, 2 months.
Thank you. And we've got time for one more question. Anybody else? Rob, did you have anything?
I did. You mentioned, James, in your great presentation and your submission as well, that the work you've done is designed around the design chilling capacity, but more often than not, and pretty much all of the time, chillers often operate below design efficiency and below design conditions. What work have you done at looking at that and how that affects the design that the designs that you've been looking at here?
Well, at the moment, the design that has been created hasn't been compared to an actual experimental data. So although it's been optimized, and in theoretically speaking, this is the most optimal design, obviously it hasn't been compared to a real life version of that. There are limitations with what's considered in the database that would exactly affect the results that have been said. So say if the efficiency came up as 80%, it would probably not be 80% in the real world. It might be somewhere near 75, but it would still be more efficient than something that was 75 according to the database. So although the numbers specifically may not be correct, the trends that they show in theory should still apply.
Okay, thank you. I'm going to move us on. So we've had an equal amount of time on presentation. So thanks, James, and thanks for answering the questions. And our third young researcher who's going to speak with us today is Mubarak Ismail from the London South Bank University, talking about investigating the performance of new alternative heat pump and using shape memory alloys. So Mubarak, you appear to be unmuted, and I'm going to leave it to you. Carry on.
Thank you. Refrigeration today stands as the spinal column for many sectors, which include but not limited to commercial and residential buildings, transport, manufacturing and preserving food and medicine, and even in aerospace. But unfortunately, it lacks the recognition and appreciation it deserves. And when often refrigeration is mentioned, it gets picked on because of the perceived emissions, as well as the low speed of advancement compared to the sector it serves. As for almost 1 century, our sector has been solely dependent on vapor compression system and refrigerants as working fluids. And even much of today's discussions are about finding refrigerants with low global warming potential and about the path towards net zero. This, however, cannot be achieved without having a closer look at alternative heating and cooling technologies, and in particular, heat pumps. This is where the idea of my project has seen the light. My project evaluates alternative technologies, and we have published a paper on that. And it focuses on shape memory alloys, which are natural smart alloys that are used in many fields, including saving people's lives. Those alloys, when stressed, they reject latent heat, and that can be used in heating. And by reversing the cycle, they absorb heat, and that can be translated into producing cooling. And since the idea is revolving around cycles, we did cycling experiments, which have shown that the material can withstand up to 70 million cycles. And that means a shape memory alloy heat pump can have a lifespan of more than 30 years. My project builds on the knowledge and analysis extracted from experimental data, and through a simulation, it works on enhancing thermal outputs from the material in order to incorporate it in the heat pump. This niche technology is called elastocaloric technology. It is non-flammable, non-toxic, and scalable. It's a brilliant, promising technology that not only is it going to tremendously participate in expanding heat pumps market, which is already significantly growing in places like India and China, but most importantly, it's going to present refrigeration as an innovative, environmentally friendly, chemicals-free technology. And by doing that, we will be changing the image of refrigeration, and we will be doing our bit in healing the world and making it a better place. Thank you.
Miriam, you're just
Sorry,
on
thank
mute.
you very much. You're absolutely on time there, so that's great. So let's move then on to questions. Any questions from the audience or questions? Joe, you seem ready to go on this one again.
You mentioned that when it rejects heat, the heat rejection was latent, but you didn't mention whether when it absorbs, it's sensible or latent or a combination of the two. I was just wondering if you could comment on that side of it for me, please.
Yeah, thank you very much. That's an interesting question. Basically, the material works, basically the grains of the materials, when they're stressed, they change, and it's a face-to-face change material. So when the materials are put under stress, they reject latent heat. And when the stress is removed, they absorb latent heat. And then the temperature of the material becomes very cold. And hence, if you pass fluid on the material, the fluid picks basically the temperature from the material, and then you can use it for cooling.
Okay, any other questions? We've got time for, I think we've got time for one more, possibly two more. Rob, did you have a question?
Yeah, and you mentioned, Mubarak, really interesting sort of insight. You mentioned scalability in terms of energy output for heating. What sort of scale are we talking about in terms of, you know, in the future? What could this look like in terms of capacity numbers?
Thank you very much. That's a very interesting question as well. Now at the moment, we're working, like I said, we're working on experiments, so basically laboratory experiments and simulation. So at the moment, we're talking about the technology can be scaled from a few watts to 1 megawatt, because as long as you have the material and you have enough hydraulic power, then you can compress the material until it gets, because the material basically changes phase and it needs a specific stress for the material to be able to reject the latent heat. So if you can provide a hydraulic pump which can get you to that point, then you can scale basically the technology up to 1 megawatt.
Okay, and we've got one question in the box here. How easy are the alloys to get hold of? Are they expensive?
No. So basically, the alloys, they are natural occurrent, and they can be found in different places. They can be a source from Europe, and they can be a source from the Far East, and they are not expensive. So even now, when we started the project, we were targeting 250 euros per kilowatt. So basically, even cheaper than the heat pumps in the market now.
And then very quickly, have you applied this concept to a built cooling system yet?
It's still on research stage. We're researching, we're working, we have a working prototype, but it's still the working prototype can provide heating and cooling equally. So yes, it can be used for cooling and for heating, but not it hasn't yet been commercialized.
Okay, not in place yet. Okay, brilliant. Thank you very much for those questions. So that's about it for our 3-minute thesis format. So everyone's had 3 minutes to chat and 3 minutes of questions. So we will invite our judges to consider against the scoring criteria, and they're going to go into a little Zoom room and have a chat about that and review also more details about that they have. I would assure you that they have actually looked at the full summary theses and documentation, so it won't be judged purely on the very short presentations. But thank you very much indeed to the 3 nominees for going through this grueling process of trying to summarize your entire life's work in just 3 minutes. So also thank you for our judges for taking time out from, as you can see, people who've won the award in the past are now in really important leadership, important roles in various different organizations within our industry. So we'll let them carry on with that work. And in the meantime, we are going to move on to our next session. So Lisa's going to bring back on board our some apprentices and trainees. Now, people joining us today all were nominated as the part of the finalists in the IOR and RAC Magazine Student of the Year Awards. So we've got 3 of the finalists joining us. We're just finding them in our list of attendees, and we'll be spotlighting them. And they're also going to be joined by Mike Creamer, and we'll sort of bounce some ideas around and have a bit of a chat. So I think we're just looking now for Luke Hale, hopefully is going to be joining us as well if he's on board. So I'm going to let them introduce themselves, and so if we track down Luke, he'll there he is. Right, great. So you're all with us now. So let's let you introduce yourselves a bit, and then we will come back and comment and talk a little bit about our industry and why we perhaps have an issue around apprenticeships and what can be done to encourage more and support apprenticeships more widely. So Ellie, you're on the top of my screen. Would you like to start by saying where you are working, where you're studying, and a little bit about what brought you to the refrigeration industry?
So I'm Anna Claire from Refrigeration as the operations manager. I started with WARE 3 years ago as admin trainee, but then I developed into project management, and I've done a few technical courses as well. I think I joined the career by accident, really. I didn't really know what the industry was about, being 17 at the time. But once you get into the industry, it's always something new to learn, and the processes and technology is always something new to learn, which is really interesting, really.
Okay, thank you, Ellie. And then moving then on to Gemma. Do you want to say a few words again? Same thing, where you're from? And I've heard this before because you were on the call yesterday, but it's always interesting. So please go ahead.
I'm Gemma. I'm from Janey Hall. I'm studying at Eastleigh College on level 2 at the moment. I'm training to be a refrigeration air conditioning engineer. I fell into the industry back in 2018, and I'm also part of the group, the WRICHP, which is, is doing me the world of good and getting onto these calls and stuff.
So that's the Women in RACHP network group.
So yeah.
Okay, brilliant. Thank you. And Luke, can you say a few words as well?
I'm Luke. I work with Lightfoot Defence. We do more like a niche market refrigeration with the military. I got into the industry through a work experience week at school. Most of the options at school were quite boring, simple things that I didn't really fancy. So I managed to get in contact with the director of Lightfoot and get myself a week's work experience, in which at the end of it, I was offered an apprenticeship upon completion of my GCSEs.
Thank you. And Mike, while you're on the line, do you want to say, how did you fall into refrigeration industry?
Well, interesting. I was a mechanical engineer to start with, and in the automotive industry, and I started designing chemical dehumidifiers, which need refrigeration to after cool the hot air that they produce. And so in specifying those refrigeration systems, I became interested in it, and then moved into the air conditioning world completely, and then refrigeration. So it's been a great journey.
So it's interesting that for everybody that it's not necessarily their first choice of career. I guess there was no careers advice to you in schools about that. I mean, if you guys, the award winners, if if you had the head of careers for UK or globally in front of you, what would you say to them about why why are we struggling to get awareness of refrigeration careers? What do you think?
I'll start with that one then. I find that it's almost unheard of in schools at the moment, because I've left school about 2 and a bit years ago now, and refrigeration is very unheard of, as I said, and it's the same with apprenticeships as well. Is that there's quite almost a negative stigma associated with them, because as was mentioned earlier, it was for people who didn't do well in school, for people who just can't do the theoretical things. Refrigeration is a fantastic combination of science, mechanical engineering, and all the calculations behind it. And as we've seen, it's constantly evolving. From the 3-minute speakers earlier, there's always improvements to be made to this industry.
Yeah, and what about the others then? I mean, what happens when you say to somebody, one of your friends, I work in refrigeration, how, and they go, what? What do you say to them? Do you want to start, Ellie? How do you respond to that?
Like Luke said, it's not mentioned in schools. It's not mentioned in colleges, really. I did start in aviation because that's what they drill into your head when you're at school. But they always ask how you come across it, and to be honest, it just falls into something when you just come across it, really. And once you're in it, I don't think people ever leave it. You just develop more and more, and there's a lot of room for developing. Like 30% of our business is aging, and we're trying to employ younger people in a traineeship, just for them to train us up for one day where they will retire and we won't have as many staff in the business.
And what about you, Gemma, then? How did you swap out of a very non-technical career, I think? How did they persuade you into doing something that was, technical, something which was a technician job?
So when I was at school, so again, it was unheard of. I said before, girls did hairdressing, boys did mechanics. There was no opportunity for for us women to go and get our hands dirty and do kind of what we want to do. And I went through much of my early 20s not really knowing what I was going to do, where I was going to be, and an opportunity came to be a trainee as an engineer, and I just thought to myself, I'll just give it a go. I don't know what I'm stepping into, but I'll try it. I'll try anything. And yeah, I've not looked back. I love every second of it, and I think it's really important if you've got good placement and good, like a good company behind you for support. I think that's the main thing that keeps me going.
Yeah, I mean, let's talk a little bit about the apprenticeship then, because I think you're all on no, Luke and Gemma are on the apprenticeship, and Ellie, you're on a traineeship, you said. Yeah. Yes. So we'll talk a little bit about the apprenticeship first. So was that attractive as a training proposition to you? Was that something that made you think actually this might be a serious career? How did you feel about that, Luke? Because I know you've stormed through your apprenticeship, haven't you?
Yeah, I got into apprenticeships because both my parents undertook a similar scheme when they were younger, and they've did quite well in their careers.